Testing, testing.
Whoa.
Running. Go, good now. Yes, that is me. It doesn't look like I'm actually changing. So I'm on the second slide. Yeah, cool. Do you know where Rudy is? And Rudy, Sam. Oh, yes. Hey, Sam. What are you doing?
Hey.
You're going to say a speech, right? Oh, yep. I,
Hello, beautiful people. There's an echo. Yeah.
Oh, maybe. Could be.
turn off your audio.
Audio is
On the computer.
Right. Okay, cool. Where is that? That is here. Nope. That one.
And now there's still an echo.
Means
Wait. Yeah, it's still there. No, it's still there. Want me to one? Hello.
long press the.
Yeah. And try this one. Nope. It's not the mic.
It's probably okay. It might be something on that side.
I can't do it. I just think it's annoying.
Yeah.
And now? Yeah. Okay, cool. Welcome, everybody. Thank you so much for gathering with us today. Yeah, always excited to see you. Stuff on next slide. I don't know if ever this is valid, but is this the password?
Yes.
For the Wi-Fi? Okay, cool. That's the password for the Wi-Fi. Connect and do the things.
Maybe just snap a picture of it because we will change slides eventually.
I'll give you a few seconds to maybe take photos of it if you need it. I see phones. Nice. All right.
Good. All right. Sweet. Hey, everyone. So, welcome to Jozi.JS. It is lovely to see you all. We have a code of conduct. It's important, but it's also quite a simple code of conduct. Basically, we're all here to learn and we're all here to share. So, be nice and considerate, be respectful and constructive. Work together. So, answer each other's questions. Be nice when we have. Don't be spammy. I think that's pretty much the code of conduct. Yeah. We have a.
Hello. I had flu a few days back, so joking. My name is Batandwa, and I'm one of the organizers for Jozi.JS. I work here. I think that's a good thing, right? Yeah, and Sam.
Hi, my name is Sam.
Sam is our newest member at Jozi.JS, guys. So she's one of the council of wizards. Please give her a hand of applause.
So outside this, I do a lot of volunteer work at any community that will have me. But mainly I work at Code and I head up the incubator trying to localize technology. Yeah. Hi, guys.
So this is the Council of Wizards. She's Sheena, Sam, Batanwa, and I'm Rudy. So if you want anything about to do with this event today, just ask any of us. Cool.
All right, so this would not be at all possible without our fantastic sponsor, BBD. This is BBD's office, as you are aware. They are giving us pizza and drinks, and they're lovely, lovely people. So thank you. This also wouldn't be possible without speakers. So who here is terrified of public speaking? Yeah, you can put your hand up. It's scary, you guys, but this is a really friendly crowd. So you can give it a shot if you have something to share, something JavaScript related, something web related. Scan this, let us know, and we'll get back to you. And if you are keen to talk, but you're like, I want to do a full talk, I just want to dip my toe in the water, then you can submit a lightning talk. So lightning talk is a 5-minute talk. Only 5 minutes, and it can be about, like, again, anything related, anything JavaScript related. Like, I always infiltrate places like these to talk about Python web dev, so you can even do that. It's okay. It's a great way to get started. It's like fun. It's low consequence. It's only 5 minutes, and it's 4 plans. So like, come and share something small, and we'll thank you for it. Yeah. Do you want to say? Tell them to subscribe to.
Yes, you can subscribe to our YouTube channel, our TikTok page, and our LinkedIn page, our Facebook page, our Instagram. Our Instagram. I know how nice it is to see yourself on social media. Yes, and also I'll be doing some interviews. Please be friendly. I'm usually scared of people. Jokes, but yeah.
All right. I think that is it. Introductory slides. Who wants to introduce me? I feel awkward.
I wanted to do the thing, but like, I was like, nah, you already talking. All right, guys, we have a treat for you today. The Council of Wizards, one of the members, Sheena, is going to be talking to you today. And the topic for today is powering up Django development with Claude Code. I think the whole idea is just using AI to code in general, right? Like, as a sidekick, more than the Django. All right,
Yeah,
cool.
yeah.
All
So
right.
like, Django is lovely. I love Django. It's a web framework built in Python. Who uses Django here? Okay. Not a lot. Who's heard of it? Who's heard of it? Okay, cool. That's better. That's better. Like, it's not the most fashionable thing, but it has like some specific superpowers that are close to my heart. And who here uses Claude Code? Yeah. Okay, cool. There's a few of you. That's cool. How many of you? Okay, cool. No, that's great. All right.
Yeah,
So
before you start with your, let me just wrap up this part. So who she is outside of Council of Wizard is she's the Python Software Foundation Director and founder of Tech. And she just like is an awesome person overall. So whoop whoop, take
thanks,
it away.
Rudy. Yeah. All right. So like, this is a kind of niche topic in a way, and I know that Django isn't the thing that everybody uses. And so even though I'm going to be talking through some Django and Claude Code stuff, this talk is really, give me a sec. This talk is really about powering up software development in general using LLMs. So this is one iteration of how you can do that, but I think there are some very transferable lessons. So I think it's important to think about these things because AI fatigue is a thing. Everybody's heard of JavaScript fatigue. AI fatigue it's hard. Like, things are hard right now. There's this deluge of new tools and technologies, and it's pretty much impossible to stay on top of it. Like, if you blink, there's 5 new breakthroughs, and You as an expert in the field are meant to know how to use these tools. And if you try to find out, if you try to like ride this wave and like research what people are doing, you come across all of these influencers who are doing like really fancy things with parallel sub-agent teams in sandboxes and they're doing it on their cell phone while they're taking their dog for a walk. And it just sounds impossible. The feeling behind is actually normal, even for the people who are leading this field. It is very normal. And if you wanted to get started, it's not immediately clear like how to get good at this stuff. So it's not clear how to do it well. It's not even clear like what good looks like. Is good like really producing code super fast, or is good producing good code at a reasonable pace? Is like it's not immediately clear. Best practices are simply just not defined. We're busy defining them right now. So it's important to talk about this. So what I'm going to share today is an approach that I follow, and I'm going to more importantly show you the thinking behind my approach. This is just my approach. It's not the final word. It's one way to think about things. So I encourage you to think about things differently and to find the gaps because they're awesome. All right. So who am I to talk about this? Hi, my name is Sheena. These are my emojis. I am one of the directors of the Python Software Foundation. So that's the organization that looks after the Python ecosystem, the infrastructure, the communities. There are a bunch of us. The reason I'm there is because I do a lot of Python community stuff. So chaired PyCon Africa last year, PyCon South Africa this year. I've also founded a thing called the Guild of Educators. So I know that there are some like education nerds in the room. Education nerds, there's a couple of you, people who are into education. There's one over there I was talking to earlier. I know, yeah. So that's a community. It's free and open for people who teach code. We have a lot to talk about because the nature of code is changing. Also founded a company called Prelude Tech. So this is my bread and butter. We do education. So advanced Python training typically, also soft skills, which are pretty hard, teacher training, agentic engineering training, stuff like that. So enough about me. I'd like to know about you. Who here has written an agents MD file or a Claude MD file? Okay, all right. There's a couple of you. All right. Who has created a custom skill? Okay, the coding harness. All right, cool. Who's created a custom command? Okay, a couple of you. All right. Who's installed a plugin? So like an agent plugin, like Superpowers, something like that. Okay, cool. So there's more hands for that. So using other people's stuff, that's great. And who's created an agent plugin from scratch? All right, just a couple of hands. Okay, so let me do something with this. I need my hands. All right. Okay, so before I go any further, like, let me just show you some stuff. So a lot of you have dabbled in agentic coding things, but it sounds like it's useful to talk a little bit about what these different terms mean. So basically, if you set up something like Claude Code, then you configure it with a bunch of markdown files that explain how it's supposed to behave and work. So you can make something like let's go here, a Claude MD file, and that explains what you're doing in your project. It's like, here's the structure, here's some commands you care about, here are some important things. But then you can add extra configuration inside a Claude, inside a .Claude directory where you can set up like knowledge about your project. Say like, okay, here are our brand guidelines, here are our colors, here's like what we care about. You can make plugins, which are basically collections of markdown files that explain how things should be used in different places. So you can do things like say, all right, if we're building admin interface stuff, then do it like so. And basically it's marked down all the way down, which seems kind of confusing, but it's like when you're configuring these things, it's about like you set up the markdown files and you explain to Claude or OpenCode or whatever you're using, like when it should reference those different markdown files. So there's some control there. So when you're working with these like agentic coding harnesses, you can install these plugins that are collections of these markdown files that someone else wrote. And there are some things that are like really, really well constructed. Some famous examples are Superpowers and Sidekick. Who's heard of these? All right. Okay, a couple. All right. Google it. It's cool. It's really cool stuff. So SpecKit is something that GitHub made, and it's a bunch of commands and skills and whatnot that enable software development. So it's like you tell it what to do, and it builds these like whole fancy things, and that's great. So earlier I spoke a little bit about the overwhelm of like building with these tools. There's actually a lot to know about, but the thing that's nice about these existing plugins is that the prompts are already defined, like all the markdown's already there. It's already using the latest features, like the parallel sub-agent teams are already like in there and implemented. All the workflows are there, all the hooks are there, all the batteries are included. I love batteries included. Everyone loves batteries. There's lots of contributors who know lots of stuff. And so it's really tempting to just like grab one of these things and try to stick it in your project and be like, do the magic machine. But personally, I've had very little luck with that. I find these things super cool. They're interesting to learn from, but they're opinionated, and their opinions don't necessarily match mine. So if you wanted to do agentic engineering on your own project, your setup depends on a couple of things. It depends on your project's needs. Your project is a unique and special snowflake like everybody else's. It's going to have its own things. It's going to have its own architecture, its own norms. You're going to have your own stack. So I code in an unusual stack. Like two people here are like, yeah, I've sort of used Django once. Like my stack is different from the standard stacks these tools are very familiar with. The structures that I work with are very different from the standard structures that these things work with. Whenever you work with a different stack, you're going to work with the idioms of that stack, and you're going to have your own as well. There are specific ways that you write your code. There are specific things that you care about. Best practices as well. Like you've got your own version of best practices. There are no universal best practices really. Like to know what the best practice is in any situation, it always depends on the situation. So you need to think about your stack, your setup, but you also need to think about trust. How much do you need to trust your code? Trust is expensive. If you're writing the new Angry Bird and there's a bug and the bird crashes, it's like, oh, that sucks. The bird, it's okay. If you are working on like a new like hyperscaler fintech, you probably need to trust your code quite a lot, and that trust comes at a cost. In the before times, if you wanted very trustworthy code, there'd be a lot of testing, there'd be a lot of guardrails, there would be automation, but there'd be a lot of eyes as well, like human eyes. When you're doing agentic coding, it still matters. Like if you're trying to build something big that's like significant, if you want to build it fast, you're not going to be able to review all the code to the degree that you usually would be able to. So you need to think about how much trust do you actually need. Maintainability as well. So I know there's a lot of younger folks here. You think code students? Who's still a student? Okay, yeah, so there's a lot of students here. And when you code, it's typically on something greenfield, right? So you start off with something that's a blank slate and you build up from there. And when you're doing that, these agentic tools, like they do a damn fine job. You give it a few commands and it spins up this like magical thing. You're like, whoa, that's better than I could code. The thing is that most projects aren't greenfield. If you are working on something serious, then you'll have the initial phase where you like just get it off the ground, build a minimum viable product, and then you'll have its lifetime, and hopefully it has a lifetime, and that lifetime has a cost. That's where most of your work goes. This is not to scale. If you try to build out your greenfield project with an LLM, it's going to be easier because you can just type in a few commands and hey, it's there. But the problem is that the code that it produces is a certain shape. Like it's often a bit more convoluted than what you would write if you were writing it intentionally. And it's often like paints you into a corner. Like one of the things a senior engineer does is they keep their options open. You always want to make sure that you're not like cutting off different avenues that you might want to go down later. So LLMs don't do that. They don't know about your future plans. You don't even know about your future plans. So there's all this convolution that comes in there. So if you were to just like use an LLM to like smash out a greenfield project, when it becomes brownfield, which it eventually does, if you're lucky, it gets more expensive. It gets harder to maintain. But of course, like LLMs will get better, right? So maybe that's not true because like if you wait, I don't know, a couple of months, then you can use better tools to just handle the technical bit and fix all our problems. The problem with that though is that messy code begets messy context or gets messy code. Like if you've got something that is kind of convoluted and its tests are all weird and useless, then if you ask an LLM to build on top of that, the LLM is a pattern matching machine. It's going to look at the patterns in place and it's going to build on top of those patterns. So messy context is a problem. The other thing is that good code makes its intentions clear. LLMs don't know what your intentions are. So it'll often not be immediately clear, like why certain decisions were made, how certain trade-offs were made. And so if you're building on top of something that's unclear in that way, it's harder to direct the thing. So better LLMs will make things better, but it still takes an amount of skill to direct the things. And on top of that, some projects just don't work if the code is spaghetti. Like if you're building something with an abstraction that other developers need to build on top of, for example, then you need some kind of stable interface and you need some kind of internal stability as well. Like if you mess that up, then all the downstream users of the code break. If you're building a big project, chances are you've got some abstractions, but some things are meant to be dev focused in the first place. So this isn't true for every project. Like in the end, it's yours to take. Like software developers, even if you are producing code using an LLM, you're producing the code and it's your responsibility. So you've got to decide where your own risk tolerances are. For the people who are still learning, I fully believe that the fundamentals matter and will foreseeable future. All right, so now I'm going to make this a little bit more concrete. I'm going to talk about a thing that I'm building in Django. So I'm building this thing called Freedom LS. It's a learner management system. A lot of people here are familiar with learner management systems, even if they've never heard those words before. From a learner's perspective, the core function of a learner management system is learner management. From a learner's perspective, it's content delivery. So it's like a clever digital textbook. It'll have videos and quizzes and maybe a way to hand in projects and that kind of thing. But it's usually like from the student's perspective, a little bit like, a little bit boring. The content is the thing that matters, not the tool. But here's the question that we ask with Freedom LS. Like, what if instead of treating the learner manager as the core user, we treated the learners and the teachers as the core users, as the primary users? What would we build? Well, it would need to be kind of flexible because the learning experience should really depend on what you're trying to teach. So I'll go back to something even more concrete. Back in the day, like I used to work for this nonprofit boot camp. I was there for about 5 years, and COVID happened, and that sucked. And we had about 250 students on site. We had to go remote, like very, very quickly. And we looked at different LMSs that existed, and none of them quite fitted our needs because they were just clever textbooks with plugins. Like if we wanted some kind of dev functionality, it would be like, oh, you can have this GitHub plugin, but it was always like this afterthought that was just bolted on. So we ended up building something, and it worked really well. So it was a Kanban board, and it was connected to GitHub, and it had peer review built in, and self-paced learning built in, and it was really cool. It worked super well for our students because it resembled a professional development environment, and we wanted to produce professional developers. So it worked super well for us. It sucked for everyone else. Like we had a few people who were quite interested in this thing because they're like, "Whoa, it's working so great for you. Can we use it for our front end design course or a copywriting course?" We're like, "You can try, but it's probably not going to work," and it didn't work. They ended up fighting the system. Different learning experiences require different things, so that's why we're building something super flexible. So it's hyper customizable. It's a Django project, as mentioned, and there's good reasons for that. It can be used as a standalone LMS. It just works like the clever textbook out of the box. But something that's really, really cool about Django is the way it's constructed. It's constructed in a way that you can override like everything. So you've got your Django project, and you can build a whole lot of apps inside your project. One for like the learner-facing interface, one for an educator-facing interface, one for like tracking of information. And then you can override that stuff. So you can think of it as like we've got a bunch of Lego bricks, and whoever wants to build on top of this can just like take the Lego bricks out, put in their own ones, change this one's color, whatever they want. Everything can be overridden and extended. Everyone here's heard of WordPress. Who's heard of Wagtail? Who's heard of Wagtail? Okay, nobody, gosh. Right, we're more like Wagtail than WordPress. WordPress is a content management system, and it's built to be used by non-technical users. Like, you can be technical and you can write plugins and stuff to make WordPress do all sorts of things. But the plugin system of WordPress is kind of weird because the plugins kind of fight each other. You can make a proper Frankenstein there. Wagtail is also a content management system. It's built on Django, and it's built to be customized and extended. So you can make it dance. You can make it like really do fantastic things, but you need technical skills. It's like a different user base. So we're more like Wagtail than WordPress. All right. So that's where we're starting. All right. So we're using generative coding practices a lot in this project, and I'm going to give you the recipe that we followed in order to do that. So step one is figure out how much trust and maintainability you need for your project. We want like high levels of trust, not like nuclear power station trust, but like not Angry Birds trust either. We also need to get things, okay, so once you figure that out, you need to figure out how to get small things right. So how do you get just like a function right, a test right, a part of your front end right? Once you can get small things right quite reliably, you work on getting big things right, and then you work on efficiency. So in terms of trust and maintainability targets, you can think about who's relying on your product and what's your long goal. For us, we've already got 2 companies who are building stuff on top of our product, and they're very, very different. So the one is a learner management system for the parents of autistic kids. So we assess the kids and then give the parents a bunch of things to do to help them understand their kid better, because it's quite a complicated situation. And then the other one is about unmanned aviation, like very, very different places. So we want to make sure that we don't mess these people up. So what that means is we need to be easy to extend. It needs to be well-structured, clear, and stable. And if we make a bug, if we make a problem, it has a blast radius. So we need to be super careful about that. On top of that, both of our concrete implementations live in very regulated spaces, and so we need to keep things very secure. So that's where we are on number 1. Number 2 is where things get a bit more interesting. So how do you get small things right with LLMs? So let's say you're using a model and you're asking it to write some code for you, and it does an okay job. You could just use a better model and it'll do a better job. That's great. And better models often come with bigger contexts, bigger context windows. So like often when a new model comes out, one of the like things people will rave about is like, oh, the context window is this big now. It's not a good thing to be super excited about, because there's actually an opportunity for more contradictions and solution of the context. The thing can get more confused the more information you try to get it to hold in its like head at the same time. So you need to, in order to get small things right, get a good idea about how to manage context. You need to also have a good idea about how to make a good agents or Claude.md file. So for those of you who haven't made one of those, like if you're using an agentic coding harness like Claude Code, Open Code, Codex, then you'll have a file that gets loaded into the context every time you run the thing. And you need to make sure that's solid, it's good. There are tools to automatically generate these things. Don't use those tools, it'll make your code worse. It'll make it worse, measurably worse. You need to take some time to craft it yourself. You need to make skills as well. So what are skills? Like, context management is really everything. Skills are markdown files that get loaded into your context as you need them. So for example, let's say you're building a full stack web application and you've got an ORM and you've got like some tailwind in the front end. When you're working on the front end, you don't need to worry about the ORM. When you're working on the ORM, you don't need to care about tailwind. So you need to make sure that you can load the right context about how you work in these different parts into your context when you need it. So skills are like a progressive disclosure thing. You can think of it as like lazy loading extra information that you need. So get good at that. And then there's kinds of scaffolding that you want to set up. Like maybe you make a lot of CRUD parts in your application. So maybe you have a little make CRUD command that has like some information about how to do that really, really well. Validation is really important. So LLMs are great because they get something wrong and they can catch themselves getting that thing wrong, then they can correct themselves. So it takes a little bit longer for them to do if you can get them to cycle, but the more validation you can add, the better it is. All right, so that's great. You can also do some perfectly normal things like write some tests. There's unit tests, there's integration tests. You can do static analysis. You can make sure that you monitor your stuff properly. So monitor like what's going on in production. Are there any weird bugs and behaviors that we weren't aware of? You can use hooks and automations to trigger these different types of analysis. And the most important thing at this point is to work interactively. So you take your robot by the hand, and you're like, hey, robot, this function, implement this function. This test, let's make it work. And you go in small steps and you keep an eye on it. And as you do it, you refine your markdown files and you make little tweaks here and there. And you learn again about context. It's all about context. It's so important. And you polish and you polish and you polish. And you get to a point where you feel like you're chasing diminishing returns. It feels like you're working more on the markdown files than you are on the code. This is actually very worthwhile. When you feel like you're chasing diminishing returns and it's not quite there yet, keep chasing those returns. There's a good reason for that. So a small improvement of the chances of success on a small task actually leads to an exponential improvement in your chance of success on larger tasks, because larger tasks are multi-step tasks typically. So like, as an example, like let's say we've got 10 tasks and you have a chance of succeeding or failing at each task. If you marginally improve your chance of success, the chain lengths get bigger. They can get bigger in a few different ways. You can get really long chain lengths just by making marginal improvement. As software engineers, we know that if you have a big task, like the first thing you got to do is break it down. Eventually, you break it down into small enough things that it becomes easy. So get really, really good at solving the small problems. All right, so we've spoken about getting the small things right. Next up is getting the big things right. How do we do that? So like this is a highly contested area. There are many different definitions floating around, different words that people use to mean different things. It's tricky, but this is my approach. So step one is figure out what the big thing is that you even want to build, because it's very easy to build the wrong thing quickly. And then you've got to break it down into small things and then get the small things right using the tools that we used before, right? So this is a workflow that I use. I'll get into it in detail, but basically it's a spec-driven development workflow. The spec-driven development is a agentic coding practice where you generate different markdown files over time, and you get closer and closer to a solution. So you don't just jump into the code. You iteratively approach working code, and you have a whole lot of checks and balances along the way. So this is the workflow that I use. So start off with an idea.md file. And the idea.md file is created by a human. It can be kind of scrappy. It could be like, I need deadlines on my LMS. Make me deadlines. And it's very loose. It's high level. And then sometimes there's a need to improve the idea. So sometimes it's useful to do some research. Now, so I created this command called improve idea, and it's built with a bunch of parallel sub-agents where fancy stuff comes in. And they'll go off and research different implementations of this idea. So it'll do things like, say like, all right, do you want deadlines? There are all these other LMSs that exist in the world. Let's go see what they do. And let's go read the forums and see what people complain about. And let's go see like what people say is successful. What are the feature requests? And then we'll come back and we'll say like, this is how I think we should do deadlines, and this is why. Maybe we need multiple implementations and some flags. Once I've got the idea nailed down, then I make a spec from the idea. And that specification, like it might ask me some extra questions. Like each of these steps does try to make the best use of my brain as possible. That's kind of important. You don't do this on autopilot. When it makes a spec, it needs to explain all of the decisions it made and why, the reasoning behind things, because that reasoning is very important. It must include success criteria. And the format is nothing fancy. So if you do some research into other people's spec-driven development workflows, they'll often have some kind of formal document that they produce at this point. I don't do that. The reason I don't do that is because reading the thing like makes me fall onto my keyboard. It's a little dry. It's a little dry. It's very boring. And I think the best way to do agentic engineering really is to optimize for your own ability to pay attention and make good decisions. And so I want to build something out that I can actually interact with and read without just like phasing out. Attention is important. You've got to manage it, and ours is faulty. So read through it very carefully and make them happy with it. And there's often some back and forth of like, oh, that's a terrible decision. Do it this way. Or like, maybe I'll ask it some questions about why certain decisions were made. Eventually, it'll get to a point where I'm like, sweet, let's go forward. After the spec comes a plan. So there are two parts to this. If there is a front end involved, so if there's like a button that changes or like some architectural change that might have an effect that's quite broad or like some new front end feature, then I'll make a front end QA plan document. And that will explain step by step how a human quality assurance tester could go through the process and see all the functionality. Now, this is cool because I, as a human, can read through that and be like, yeah, it should work like that. Or like, no, that's not what I meant at all. So I can, that's another point where I can look at it from a different angle, which is really, really helpful. The other thing is to plan how the code changes are going to happen. So like what files need to be created or edited, what functions need to be made, what tests need to be written, what do we need to look out for, what needs to be installed. This happens in two passes. First pass is we just make a plan. And the second pass is we go over each of the tasks and we say, which skills can I apply here? So remember, skills are progressive disclosure, they're lazy loading. Often coding harnesses are bad at discovering the skills that are needed at specific points in time. So it really pays to be intentional about saying like, use this skill here, because otherwise it'll sometimes just make stuff up. So having a second pass where it's like attaching different skills to different tasks is really, really handy. Then there's writing the code. I just say implement plan, and then it goes off, and often it actually does it in like one shot at this point. So what it does is it'll take all the tasks and it'll put them into batches and say, cool, this batch should happen over here, this batch should happen over there. These batches get executed again by sub-agents. Now, sub-agents are used here for a very specific reason. It's not so I can go faster. It's so I can protect context, because each sub-agent has its own context. And so it lets me have like a little sandbox around like how each bunch of tasks are being implemented. So like if, for example, they'll often be, like you don't always want them to each other. It just like the more you put into a context window, the dumber it gets. So you want to separate it out as much as possible. Each sub-agent will write the code. It'll also run a bunch of tests. And then it'll call a separate agent and say like, hey, can you review my code? So now something else will swoop in and be like, okay, how about this? How about this? And those two will talk and update things according to anything that come up. So it often makes a lot of sense to like have one thing produce an artifact and have another like review that artifact and give feedback. All right, then the next thing, if there is a front end, then I'll generate a QA report. So this one's kind of not that intuitive at first glance. So there's a command to do it. It makes use of Playwright MCP. Who's heard of Playwright? Okay, fantastic. So good. Who does front-end development here? Just all right, okay. Not that many people do front-end development. Really? Okay. Huh. Okay, cool. Very lovely. It's lovely for front-end testing. It's like a browser automation tool. It's like Selenium, nice. And it's like which I like. So basically what this agent will do is spin up a browser and it'll go through the QA flow as if it was a human. So I'm quite particular about this. I tell it, you're not allowed to write code, you're not allowed to run tests, you're a human being, only click on stuff. If you need something to be put into the database, ask that agent. They're very helpful. They'll help you spin up some data from the database, but you're not allowed to do it yourself. And the reason I do that is because these things cheat. Like if you ask an LLM to do something, it'll go in the shortest possible path. It'll be like, cool, I'll write some tests for that. But if you're testing front-end interactions, it's often not able to write appropriate tests because it'll assume something works at a certain way or assume something isn't overlapping. So yeah, it's good to act like a human. I then execute the thing on multiple screen sizes. So if I implement a feature, it'll test it on the big screen and then on like a tablet-sized screen and then a small screen. You can even test it on multiple browsers if you wanted to. I haven't done that, but it is doable. This is very token heavy, but it's okay because it saves me. Like it solves problems, it spots problems that I otherwise would have to find like manually with my own eyes. So it takes a bunch of screenshots and it generates a report. I can show you an example of a report. I think I've got one here. Yes. So this is a report that it creates. So this is from an early feature. It's like, all right, we want to make a thing that shows cohort course progress stuff. It's got a bunch of tests that are passed. It's got some screenshots in there. And then if I keep going, then it'll show that there was a bug. It's like, oh no, the sidebar does not also collapse on mobile. And it's got this picture. Now I can say, like, go and fix it. And I can say fix it using TDD. There could be, like, so it's something I should do and haven't yet decided to, like, spin up another agent to do the fixing and rerun the test. So there's still work to be done here. But this spots things that weren't in the tests at all. And it spots, where are we? And it spots stuff that is potential to what I'm even working on. So while it's doing the QA, it might notice something funny. Be like, oh, that thing over there, like, seems broken. I don't know when it broke, but it seems broken. And then I can make a judgment call about, like, if I should deal with that or not. So that is super, super handy. Oops. All right. And then finally, it's just like me reviewing the code. So I'll do a review on GitHub. I like reviewing stuff on GitHub because the PR is displayed in a way that's quite nice and readable. I can make quick fixes there. And generally, if I find a major problem at this point, it means I messed up like a few steps ago. Like usually when I get to the point where I implement the code, it doesn't mostly right on the first go. I just like press play, go away for 10 minutes, do something else, and the code is there with some minor bugs, and then I can fix itself, and it works really, really well. So you got to fix problems early. That's important. This is just like life skill, really. The earlier you solve a problem, the cheaper it is to fix. When it comes to stuff like agentic coding, it's not deterministic. It's chaotic. Like if you give an LLM the same instruction, something different. If you give an LLM a slightly broken, weird instruction, it's going to do something different, and that different kind of compounds on itself, and things get really out. So, like, if you can fix a problem in the idea phase, in the idea phase. If you can fix it in the specification phase, fix it in the spec phase. If you can fix it in the plan phase, like, pay attention to the early steps, and as you proceed, you can, like, relax your attention somewhat. But those early steps are pretty critical. And the other thing is that technical debt still matters. So remember earlier I said, like, if you have technical debt, it's messy context. LLMs are pattern matching machines. If you let this process produce messy code that you wouldn't stand behind, then realize that it's going to produce more of that. So there's still a space in here to chase those diminishing returns. Be like, whoa, you're doing some crazy things with testing. Why did you test that? Why are you testing that our configuration options are like this? We're going to change the configuration option. That's what configuration is for. Silly robot, you can fix it. So this is still a time to like review the code and make sure that you take your learnings and pull it back into the markdown. All right, so you got to pay attention. You can mind your context, find bugs and data early, and try to keep your head in the game. Like if you can optimize for your own ability to pay attention and make decisions, then you're winning. All right, so the next step is get big things right efficiently. This can mean a lot of things to different people. It could mean quickly, or it could mean cheaply. Depends on who you are and what you're optimizing for. Git workflows are great because you can run a whole lot of specs in parallel. I'll typically do like 4 in parallel at least. I'm kind of limited to how much I can pay attention and how much I'm able to switch between things because like now I'm a bit of a bottleneck, but that's great. So again, there's a lot of students in the room. It's weird, right? It is weird. And when you learn it, you're like, what's this for? It's weird. It's so useful. And it's such a power up when you're doing this kind of work because it gives you the chance to work in parallel in a way that's really safe. Cost efficiency is also a big thing. Like if you just hit everything with the biggest, most powerful model, it's expensive and it's slow. So if you can say like, cool, these things need to use the expensive, powerful model, and these things can use the smaller model, and you can control that, and that's great. So you need to test it out and see what works. And at your attention, and avoid scope creep. This is a big deal, actually. doesn't know what scope creep is? Okay, so scope creep is when you have a project and you're like, cool, I need to build this thing. Oh, but wouldn't that be cool? Wouldn't that be cool? And wouldn't that be cool? And then you end up with something that's kind of complicated, and you didn't necessarily build the thing that you intended to in the first place because you're distracted by all of this stuff, or it ends up being more expensive. It's a problem. And like we as software developers are often like really curious, and we like building these things. It's a puzzle to solve, and we got all these ideas. It's so tempting all the time. Like even if you're coding everything yourself, it's tempting. With LLMs, it's more tempting because the LLM is going to be whispering in your ear and saying like, hey, should we do this? Should we make it like this? Should we make it a bit more fancy? Should we add this extra thing? And you're going to be tempted to say yes because the LLM is going to write code, right? So it's fine. Like it costs nothing. It does cost something because like when it comes to scope creep, like there is a cost of integration, firstly. So the more stuff you have, the more stuff needs to talk to other stuff. And so that adds a bit of a tangle to your code potentially. It also takes away your attention because now like if you had like 4 specs and you're running them in parallel, and this one's got scope creep, and this one's got scope creep, and this one's got scope creep, you end up like, instead of like you switching your own mental context between things that you actually need to do, you're like, let's just like wrap up the scope creep. Let's just wrap up the scope creep. And it really creeps into your own ability to pay attention. So there's a real cost of complexity, integration, and more attention. So avoid it. Self-discipline is still a thing in the age of LLMs. So you can copy my approach. It's totally cool. I welcome you to do so, but I think it's better for you to choose your own adventure. So be structured about things. I don't think it makes sense to go and use the biggest, like fanciest hammer you can find on the internet and hit your code with it. I think it makes a lot of sense to like progressively like pursue your own abilities in the space and figure out which tools are good for which jobs and why. It's not just about code. The skills that you gain in doing these kinds of things transfer into other places. With diminishing returns, it's really worth it. And do what makes sense for your project. And the most important thing is like actually learn agentic engineering skills because things are changing so much right now. And if you get a good grasp of the basics, then that's going to serve you for a long time. Speaking to the students again. All right, so that's it. Thank you, everybody. Slides are there. Yay. Yeah, and I've got some Claude Code Max vouchers to give away, $100 a piece. Well, you don't have, Claude will pay. Yeah. Let me get them and then I'll give them away. Okay, I'll be back in a moment.
No worries, I wanted to voucher.
Thank you. It's okay. Thank you. I should have brought them to the front. Okay. Yeah. Okay, I'm prepared. There was a question. Yep.
Okay. My question is, right, sorry, I wrote it down. Okay, so obviously, as devs, we're always exposed to breakthroughs with LLMs, and every other day a new LLM comes out, right?
Yeah.
My question is, how do you handle the whole balance of compliance with your workplace? So obviously, if you want to build a new LLM, you start using the agentic workflows. Next thing you hit with a compliance issue.
Okay.
So how do you manage that approach of being like, okay, cool, I really want to use this tool, but I'm scared of how it'll catch up to me later on. So yeah, how do you manage that balance?
That's a good question. There are multiple levels of compliance. There might be like some internal tool thing that you need to deal with where you've got like some security folks who are like, no, don't use that. That's a hard battle to fight because there are politics involved. LLMs are often insecure by default. And so a really cool thing you can do is there's also stuff around like where you're allowed to send data. So sometimes in certain domains, you're not even allowed to send data like to another country. It's all got to stay local. And that's hard to deal with if all of the models are like in America and China. So there's a couple of different ways to approach that. So to keep the data local, there are models that you can self-host that are actually really, really good, that are like comparable to some of the like near frontier models. So like if you look at benchmarks of models over time. If you look at the frontier models, they're of course like going up into the side, like everything's getting better over time, like all of the benchmarks, and that's great. If you look at the open models that can run on consumer hardware, same, but time shifted. That time shifted 6 to 12 months. The other thing to know is that the better you get at prompting these things, the better the harnesses around the tools, the better they work. So like putting a lot of effort into just like how you craft your prompts, how you check things and whatnot, make them better. So you can conceivably run stuff locally if you're careful about it. And that stops that compliance issue. It means that the data's not going anywhere, nobody will try to stealing it. The other thing to do is to use it for approved purposes. So to say like, okay, security folks, you don't want me to write code for that. This is fine. Can I use it to assess the code to see if there are any security holes that we've missed? Is that okay? And see what it comes up with and get some buy-in. So playing that political game is a whole thing. Personally, I found it quite useful for spotting potential compliance issues before they happen, because you can say like, okay, ISO 27001, what does it say? Like, can we like take some of its requirements and build it into hooks and build it into like static analysis and build it into our tests so that we don't like fall into problems? Like what I showed you here is actually a simplified version of the workflow that I have, because like the spec and the plan and everything gets reviewed from multiple angles. So there is a security review aspect. There is like a threat modeling aspect to it as well. So you can build that into workflows. So if you show people that you're doing things safely, then I think that helps. Like maybe you're just generating the ideas up to the spec and then you implement it yourself. Like there's all sorts of different ways to do it. Yeah, that was a really good question. I'm going to give you a thing. Yes. Could you, who's next? There's quite a lot of hands.
Hello. Hey.
Okay, there's one over there. There's a bunch in the front as well.
Oh yeah. So for me, in terms of security, right? Do you still follow like the sort of traditional way of doing your sort of pen testing or probing of your system, or do you still use like LLMs tools to help you do your like? How do I secure my system to be better?
Sorry, I'm struggling to hear you. Could you hold it like?
Oh, hello.
I think you're moving it a bit.
Oh, so I was saying in terms of like security, right? Do you still follow the traditional way of doing like your probing, pen testing, and so forth, or do you still use like LLMs to help you sort of do your cybersecurity frameworks?
Sorry again.
Okay. So
Alright.
So in terms of like your security, right? Do you still follow the same traditional way you go about sort of testing how secure your system is, or do you still use LLMs in that case?
So both. I have some. So I do some dependency scanning. So that happens all the time.
Okay.
I use LLMs to check certain things. Like there's a lot of, so Django, one of the reasons I really like it is that it's like pretty secure by default. You can shoot yourself in the foot, but Django is not going to shoot you in the foot. It's really built for security. So that helps. But there are still like some known patterns of like ways that you can make it insecure, ways that you can allow things like different types of injection attacks. So it's useful to have an LLM scan through recent changes in order to say like, are we introducing this kind of threat? Sorry about making you repeat yourself so much. We always say we like time. Could you pass this back to him?
There was a question.
There were a couple of questions in the front. Some patient people.
Please keep going.
Okay, I think my question is pretty simple. You mentioned that it's better to fix errors as you move along. And so what I want to know is, because as you develop, you're trying to make your costs as low as possible. So at what point do you incorporate cloud? You know, while you're busy building, do you do it as you go so that you can fix the errors even in the cloud, or put the link with the cloud, or do you kind of like build and finish and then you incorporate cloud?
That's a good question. So it's basically like, do you want to deploy your code before you're quite 100% ready?
Yes.
It depends. I don't think there is one clear answer. It depends on where you want your code to run. And if your code is something that can be deployed in a pretty standard way, and those standards are well defined, and you understand those standards, then you don't necessarily need to do that. But generally speaking, you want to get feedback from the real world as quickly as possible. So it depends on what you build. If there is a client, if there is somebody like a human client, not like a client, who you are building the thing for, then it is useful to release early versions of it so that they can poke around and see that it's working and be like, oh no, I didn't mean that, I meant this. So from that perspective, it's really good. And yeah, like deployment is something that's, in some ways it's well understood, in some ways it's tricky. It depends on what you do. Yeah, so like with my stuff, for example, it's mostly like Django, well understood, Postgres, well understood. Like every part of it is like, it's a normal thing.
Okay, let me be more specific then, because I'm building something, and so in this building, we're struggling. Well, doing the AI stuff, it's a struggle to actually get like this thing to be saved and retrieved. From like so part of me kind of feels like, why don't I just go automatically into AWS S3 and then we just direct it to that so that when it retrieves it, we're able to get what I'm saying? Because it's like you're building a photo library, for argument's sake, right? And now the code writes perfectly, everything, but then now the problem is being able to retrieve the photos. So, from like, I don't know if that makes any sense.
No, it does make sense.
Okay, so do I jump into AWS and get those free credits, or do I just keep it?
Okay, so there are, again, like, the answer is always it depends. Like if you say it depends, then people think that you're a senior engineer. So one of the things that sounds like you're struggling with is like, how do you actually get information from the cloud, or is it like how to get information from local?
Everything is local now.
Okay, cool.
So now when you build the thing and you say save,
so
it saves, but then it struggles to put it in like a photo gallery that you can then go to the gallery and see.
So it's saved to disk, and then you're struggling to like retrieve it from disk and display it on the screen. Okay, so I think debug that, because you're probably going to hit the same problems on the cloud. It's very likely. And in any case, whichever one you're doing, you're going to want to test it, right? And if you're writing unit tests that require you to be connected to like an S3 bucket, then that's going to slow you down drastically, and it's going to make your tests like reliant on something that you don't have locally. Like you want that isolation. And so what I'd recommend is having an abstraction of sorts, where you're like, okay, when it's in this mode, we're fetching everything from a local disk, and when it's in that mode, we're fetching it from there. Or you can have like multiple backends that fetch and save the files. Yeah. Thank you. You could also, like, there are S3 like compatible things that you can install locally that you can test against as well. But like try to isolate. 1 minute left.
So hi, my question is about building your own tools. So obviously, you presented your project, which was this sort of custom LMS, because the sort of the tools that existed didn't do what you exactly needed. But I'm sure there were compromises which you could have made in which to sort of to accommodate those sort of cons. So my question is sort of related to AI, but it's like, where does that line, I guess, in your opinion, fall between building your own tools and compromising with the time and the effort that you need to spend, but also between, compromising and sort of maybe I can be okay with working with this tool even if it doesn't have the cons. And also with, I guess, AI existing currently and its capabilities of helping you essentially be a second engineer, like, do you think there is the worthwhile of even like spending that money on using AI as a sort of second engineer rather to build your own tool rather than spending that is essentially buying the other thing.
Okay.
Does that make sense?
Yeah. So
Yes.
build or buy.
So where does that line sort of fall
Yeah.
for you?
It's difficult. Again, it depends. Like I argue with myself about this a lot, to be honest, because things like SpecKit and superpowers, and there's a bunch of other ones, and they're fantastic pieces of tech, but they're not built for me. And so, like, I have struggled to use them, and they're hard to like understand without like really diving deep into the things. And I think if you're building something that's quite specific, then you want tools that work for you. So I think there is, I do think it makes sense to at least like understand how they work, but you can always try these things out and see if you can make them work for you. So that's on the LLM tool. On like other tools in general, like it seems like it's really cheap to build stuff, but like let's take LMSs for example, pretty well understood field. Like there's so many of them out there. I can tell you from building one that they're not simple. There are a lot of like things that I didn't think of. I was like, whoa, okay, I need to make this decision. Like, how are we going to handle this? And it's not obvious. Like, there are dark corners that you have not explored. If you want something reliable, like remember the trust costs something. It costs like either a bunch of tokens and thoughtfulness, or it costs like your own time and attention. So it depends on like how reliable you want the tool to be, and if you really need it. Often, like if you add things up, like cool, I could pay $20 a month, or I can build this thing. It'll take me a month to build. What's my time worth? Okay, I can really like sink that time in, and I'll never have to pay $20 a month anymore. Like, does it add up? Are you sure that you're building the thing that you want? Maybe this profile is like, if you pay the $20 a month, then you can stop after 3 months because it turns out you don't need the thing anymore. So yeah, you gotta weigh it out, and it depends.
Okay, that's it.
Sweet.
All right, thank you, Gina.
Thank you.
So Sheena will still be around. So if you have questions, grab pizza and just have a chat with her. So yeah, that's it. So we can have pizza, we can have drinks, and then networking. Thank you, guys. Please be mindful with the pizza. Don't take 1,700 slices. Thank you.
Sorry about the mic reading. I was very confused. I was listening to the guy, like, I've already made a
We actually forgot to do it.